We are having six different classifications. There are the second one is just the primary one, okay, which also has the subdivisions in the later form. Okay, so these are the six classifications of the transducer. First one is the primary and the secondary transducer. We can have the primary, we can have the combination of both primary and secondary. Okay, but we cannot have alone a secondary transducer. Okay, then based on the principle of transduction, we are having multiple classification: active and passive, analog and digital, direct and inverse. So these four are the main classifications: primary and secondary, active and passive, analog and digital, direct and inverse. Whereas null and reflection is also one of the type, but where it also comes under the subtopic of the primary and the secondary. Okay, so we'll discuss all these different classifications in detail. First one is the primary and the secondary transducer. Okay, so the function of transducer, okay, transducer usually have the electrical output signals. Not necessary that always it will have the electrical output, but mostly it has the output in the form of electrical signals. Okay, transducer which comprises the entire sensor transducer stage, okay, has the two major components. Okay, and those two major components, one is the sensing or detecting element, and second one is the transduction element. So the first one, the sensing or detecting element, is also called as the primary transducer, and the second was transduction element is also called as the secondary transducer. Okay, now what is the function of the first one? As the word suggests, that sensing or detecting element. Okay, whatever may be the input which is supplied. Okay, whatever may be the input which we are supplying, that can be, suppose if we are using a weighing machine, okay, the weight of the object, okay, that is the input. Okay, so the response to the physical phenomenon or change in the physical phenomenon is nothing but your sensing or detecting element. So the first one, you are supplying the input signal to the primary transducer and it will give you the output. So that you can have a transducer which will directly give you the output, or later on that particular output will get converted in some another form, and that another form will give you the final analogous signal. Okay, the simplest example I have already told you, the word on pressure tube gauge. Okay, जिसमें पहले क्या होगा कि आपका जो भी प्रेशर होगा, pressure will get converted into the displacement. Later on, that particular displacement will get converted into the voltage. Okay, so the pressure which gets converted into the displacement is your primary transducer stage. Now that displacement will get converted into the voltage is your secondary transducer stage. As you can see it over here, pressure in the Gordon tube, initially it gets converted into the displacement. Now the displacement will become the input for the secondary transducer, which is also another element. That another element is LVDT, which is the familiar example. You must have studied the principle and the working of LVDT. What is the full form? Anyone? LVDT device, linear variable differential transformer. Okay, linear variable differential transformer. We are having a working principle of LVDT in chapter, I think unit 2 or unit 3. That time we will discuss about the detailed working principle, different components of LVDT. How does it work? Okay, means how we convert the displacement into the voltage. There are different parts. Okay, construction as well as the working principle we will discuss. Okay, most of the for most of the particular transducer elements, okay, we are having the construction and the working principle in second and the third unit. Okay, that time we will discuss. Okay, here we are just studying about the primary fundamental things about the transducers. Okay, so this is the primary and the secondary transducer. Now we are having several classifications or several types of the primary transducers. Okay, as you can see, these are the mechanical transducers and their operation. So contacting spindle, pin or finger, okay, which converts from one displacement to displacement. Okay, so if you are applying some particular force and the displacement will take place. Okay, so that is one of the particular element, okay, which comes under the category of the primary transducer. Elastic member, Gordon tube, bellows, diaphragm, pressure to the displacement, which converts pressure into the displacement. Okay, then proving ring, spring, force to the displacement, mass, seismic mass, forcing function to the displacement, pendulum, manometer. Okay, you must be knowing about the manometers, right?
Yes.
Okay, EME में आपका हुआ होगा, right? Okay, which converts the pressure into the displacement. जो manometric tube है, that part we have already discussed. Okay.
Yes.
If you consider the blood pressure measuring instrument earlier, which was used, okay, which has the variation in the liquid, whatever is the liquid which is filled in the tube, okay, so that pressure gets converted into the displacement, and with the help of the difference in the height between that particular liquid, okay, we calculate the pressure. Okay, so we are converting pressure into displacement, right? Then some other examples: thermocouple, bimaterial, temperature strips, okay, hydrometer, venturimeter, orifice meter. All these particular instruments, okay, you will have a detailed working principle of these particular instruments. Either in some of them will be in the strength of material, some of them will be in the fluid mechanics, some of them will be in the fluid machinery, and few of them obviously will be in the triple A. Okay, so right now the degree student must be aware about the orifice meter, venturimeter, pitot tube. Okay, you must have studied it in fluid mechanics subject.
It's in base.
No, degree students. Anyone heard about the venturimeter?
Yes,
orifice meter?
yes. Venturimeter we had previously in 11th, 12th.
What is? Why we use the venturimeter? What is the function? Main function of venturimeter. To record, main purpose is to record the flow rate. But the flow rate is recorded by measuring the pressure. Okay, so velocity. So any fluid is flowing to the pipe. Okay, so we install a venturimeter. Okay, that is a narrow, the diameter will suddenly decrease, and we come to know about the velocity. Means velocity is our input, and with the change with that particular flowing fluid, we calculate the pressure, and on the basis of the pressure we calculate the flow rate. Okay, so these are the devices, okay, which are used as a primary transducers, okay, which converts one form of energy into another form, means which records, which has a certain particular reading, and we convert it into some other form, right? Yes.
We had orifice meter in our school as well.
Yes.
For restricting flow and reducing pressure.
Yes. Orifice meter is largely used for the gases, whereas venturimeter is largely used for the liquids. The purpose is same. Okay, to record the pressure. By means of recording the pressure, we are measuring the. Ultimately, we are measuring the flow rate. Okay, but venturimeter, okay, it is large in the size. Okay, you will observe it in the fluid mechanics lab, fluid machinery lab. Okay, generally एक हमारा एक टर्बाइन है. Okay, उसकी ओवरऑल लेंथ जो है इतनी बड़ी लेंथ है. Okay, and ये साइज का आपका वेंचुरीमीटर है. ये पूरे जितने 5 स्टूडेंट बैठे हैं वो बेंच के साइज का आपका वेंचुरीमीटर है. So that large size venturimeters are used for the liquids, whereas the orifice meters are used mainly for the gases. Okay, because they are having small in the sizes, whereas pitot tube is generally used to record the velocity. Okay, sorry, it takes velocity as an input and it records the pressure. Okay, change in the pressure. So these are the multiple, okay, mechanical transducers. Okay, some of them are primary, some of them are secondary. So second classification on the basis of the transduction. Okay, so it depends. The classification is on the basis of what is the input which you are supplying. Okay, so what is the input quantity which we want to transform. So that can be the capacitive type transducer, that can be the resistive type, or that can be the inductive type transducers. And we are having all these three classifications in the next part, that is active and passive. So all these type of the capacitive, resistive or inductive transducers comes under the passive transducer part. Okay, we will discuss the next classification. Okay, the transducer can also be piezoelectric, thermoelectric, magnetostrictive, electrokinetics and optical. Okay, it depends. How you are classifying these particular transducers on the basis of the signal which you are providing. Whether you are providing the signal in terms of voltage, whether you are providing signal in terms of current, whether you are providing the signal in terms of a magnetic field which is generated, okay, or whether it is a particular image, okay, which you are observing from the Okay, active transducers are those they doesn't require any external power source, means they doesn't require any auxiliary power. Okay, they operate by their own. Okay, they generate their own voltage or current output. Okay, so the example is the thermocouple. Okay, thermocouple doesn't require any particular power. Okay, that will just sense the temperature, maybe temperature of air, maybe temperature of any particular exhaust gas, or maybe temperature of water, temperature of any particular fluid, or temperature of any particular solid object. Okay, so temperature of any substance can be sensed and it will directly give you the output. So it doesn't require any external power source. Okay, that is your active transducer. Piezoelectric crystals and photovoltaic cells, that also doesn't require any auxiliary power. So the input is directly gets converted into the output without any auxiliary power. That is active transducer. And obviously the passive is opposite, which requires the auxiliary power, means outside external power is required. Unless and until you don't supply the outside power, okay, they are non-active. Okay, they are not in the operations. Okay, so auxiliary source of power is required for the passive transducers. They remain passive in absence of the external power. Passive means obviously not in the operation. Okay, they are idle when you don't supply any particular external power. Resistive, capacitive and inductive transducers are all passive transducers. As we know that, okay, for all these particular types, resistive, capacitive, inductive, we require the external power source. Okay, so all these particular categories comes under the passive transducers, which require some external power to operate. Okay, to pass the signal from one energy into another energy, okay, they need some external power. Okay, so the familiar example, if you want to take, you can take in case of IC engine, the smoke meter. Okay, जब आप PUC करवाते हो आपकी गाड़ी का, okay, तो वो जो मशीन होती है, okay, it will sense, okay, the gases. Okay, जो स्मोक मीटर होता है आपका, okay, स्मोक मीटर में सभी एलिमेंट्स है, CO, CO2, NOx, हाइड्रोकार्बन, जो भी पर्टिकुलर हैजर्डस एलिमेंट या जो भी एग्जॉस्ट गैसेस में पेट्रोल एंड डीजल बर्न होने के बाद, कंबशन होने के बाद जो भी प्रेजेंट हो सकते हैं, okay, वो सब एलिमेंट्स वो मशीन्स में होते हैं. Okay, and exhaust gases sense करके, okay, that just record, and obviously it requires the external power to operate. Okay, उसको रन करने के लिए external power required है. Okay, so that comes under the passive transducer, and that will provide you the signal. Your signal will be in the form of the elemental composition. What is the composition of the for that particular exhaust gas? What is the composition? What is the percentage of CO? What is the percentage of hydrocarbon? What is the percentage of NOx and all those things? Okay, whether it is a smoke meter or whether it is the gas analyzer, density analyzer. Okay, so it is the same. Strain gauges or the potentiometer is the familiar example. Okay, you must be knowing about the strain gauges, right?
मतलब strain transducers.
हाँ, yes. Strain gauges, strain transducer both are the same. किस लिए यूज करते हैं?
वो ऑब्जेक्ट पे मेटल जैसे किसी ऑब्जेक्ट पे लगा के उसमें क्या स्ट्रेन डेवलप हो रहा है वो पता चले.
डिस्प्लेसमेंट और वो सब. हाँ. Okay, check the displacement, failure, कि कितने पॉइंट पे इलास्टिक लिमिट होगी, प्लास्टिसिटी कितने पॉइंट पे आएगी. So for that purpose we use the strain gauges. ये आपका स्ट्रेंथ ऑफ मटेरियल में you will use multiple strain gauges, and most of these particular, the most important thing, most of these particular transducers, okay, you are going to use in the M lab itself. Okay, so whenever you are having a practical, okay, if you are using any apparatus, okay, for every apparatus, as you are performing the experiment, okay, you are supplying certain input and you are getting certain output. Okay, input in one form, output in another form. Okay, so please ask either the lab assistant or maybe the faculty member, okay, what is the type of the transducer which is used in that particular device. Okay, वो practically आपका concept clear होगा. Unless and until you don't see a physical device and you understand which type of transducer is there for this particular type. Okay, because we are having 10 experiments, you will have the 10 devices. Okay, each device will have a different transducer, right? और कुछ normally एक separate demo model भी है हमारे पास. Okay, that can you also see. Okay, whenever if you are having an experiment on the basis of that, okay, transducer का कोई recently अगर experiment ऐड किया होगा तो उसमें आपका पूरा ये कवर होगा. Okay, the next type is the analog and the digital transducer. Okay, so analog transducer is obviously the type of a transducer, okay, which changes with the time, okay, which provides you the absolute values 0, 1, 2, 3, 4, whatever may be the reading. Okay, so based on whether the output generated is a continuous function of time or it is a discrete time, okay, that particular category comes under the analog and digital. Okay, so what is analog? Where the output is a continuous function of the time. That particular is called as the analog transducer. So input converted into an analog output, that is a continuous function of time. That is the LVDT. LVDT हमने discuss किया. LVDT input is the displacement and output is the voltage. So that gives the output is in the form of a number. Okay, it is in the form of number. So thermocouple, the strain gauge, what is the displacement? Okay, that is the strain gauge, that will give you the absolute value or the magnitude. Okay, thermocouple again, the temperature 5 degrees, 7 degrees, 30, 40, 50, whatever may be the value. Okay, that is your analog transducer. And whereas obviously the digital one, it will just give you the signal. Okay, the waveforms. Okay, so either 0 or 1 type of the, whether it is the signal is received, the signal is not received. Okay, or maybe only a graph. It can be the linear, okay, or it can be sine cosine type of the curve. Okay, so that is generally used for the non-quantitative measurements. Okay, so we can see over here the light source is provided to the encoder wheel. Okay, and this is the light sensor, whether it is rotating at the same speed or not. Okay, so for such kind of applications we are using this digital transducer. So input converted into the electrical output, which is in the form of the pulses, but not in the absolute number, not in the magnitude, in the form of the a particular waveform. Okay, or only 0 and 1, generally which the language which we use. Okay, the whether we are getting the output yes or no, that's it. Okay, it doesn't have any particular magnitude for that output. Okay, so that comes under the digital transducer. Example, shaft encoder, which we have discussed, linear displacement transducers using conductive or non-conductive contacts. Okay, so all these are the digital. Wherever we are not getting any particular physical measurement, any particular absolute value, that category comes under the digital transducer. The next one is the direct and the inverse transducer. Okay, so the direct transducer, when a measuring device measures and transforms a non-electrical variable into electrical variable. It means that your input is non-electrical variable and you are converting non-electrical variable into electrical variable. That comes under the, what is the category? First category, that's come under electrical to, sorry, non-electrical to electrical. Which one? Direct transducer. Okay, can you tell me the example where your input is non-electrical quantity and output is the electrical quantity? Any example? Microphone.
Thermometer.
Okay.
Digital thermometer.
Microphone, can you decode? Input, what is the input in the microphone? Audio.
And
the voice.
Output is direct current.
Output is obviously the current. Very good. Okay, that is your perfect example of the direct transducer. As you can see it over here, microphone. Okay, the audio over here. Okay, and it is being converted into the current, that is the output. Okay, जो amplify होगा, okay, जो भी आपका voice है वो amplify होगा. Okay, clear as well as the louder. Okay, clear भी होगा and louder भी होगा, right? And what is the second one? That is the inverse, which converts the electrical input into non-electrical output. Reverse as that of the direct. So obviously the second one is the speaker. The input for the speaker is obviously electrical contact, okay, and the output is obviously the audio, okay, sound. Okay, that is the perfect example of the inverse transducer. Okay, so direct and inverse. Direct transducer, input is non-electrical contact, okay, and output is electrical. So it converts non-electrical quantity into electrical quantity of the measurement, whereas the inverse is, which is for the inverse transducer, input is the electrical contact or electrical quantity measurement and output is non-electrical element. Okay, so the perfect example, microphone, which is input is non-electrical element, which is our voice or audio, and it gets converted into the signals, electrical signals. Okay, it amplifies. Okay, enlarge होता है हमारा, louder होता है as well as clearer, and the same is getting transferred to the speaker. Okay, for the speaker, the input is obviously the electrical signal and output is obviously the voice, the audio. Okay, so which is again a non-electrical element. Okay, so this is the direct and the inverse transducer. As you can see, thermocouple is also one of the direct transducer type. So thermocouple input is non-electrical, that is either the air or maybe any particular physical quantity. Okay, that doesn't have any particular electrical signal. Okay, and output is obviously the temperature. Okay, so that senses the temperature, which is the electrical parameter. Okay, so these are the examples of direct and inverse transducers. Last, this is the inverse. Okay, speaker, piezoelectric crystals. Okay, in case of piezoelectric crystal, obviously input is our voltage. Okay, which gets converted into the displacement. Okay, so displacement is obviously not the electrical parameter, or it is not an electrical signal. So the working principle of piezoelectric crystal, not a working principle. The input of piezoelectric crystal is the voltage, and we convert that voltage into displacement. So displacement is obviously non-electrical element, right? Last type is null and the deflection type transducer. So null transducer, null displacement transducer, the word suggests that it will have a zero reading. Okay, means the balancing, either you take the balancing of the weight or balancing of the pressure on both the sides, so that the pressure gauge or maybe whatever may be the weighing scale, okay, your recorder will show you the zero reading. Okay, simply a balancing of the units on both the sides. Okay, so you can see the example over here, a dead weight pressure gauge, as you can see. Okay, so what is the on one side? Okay, on one side you are having a particular pressure. Okay, maybe pressure of any particular fluid. Okay, you have a recording and you are putting on the weight so that the pressure will get increased. Consider a piston cylinder arrangement. You must have studied in the thermodynamics in EME. Okay, if you are having a piston cylinder arrangement, and if you keep on putting the weight on the piston, on the top of the piston, and inside the cylinder obviously we are having certain substance. Okay, it can be a normal air or it can be any compressed gas. Okay, if you keep on putting the weight on the piston, what will happen with the pressure of that fluid which is inside the cylinder? It will increase. Okay, similarly over here on the other side we are keep on adding the weight, so that will get nullified and it will show you the zero reading. So that type of the transducers are called as null transducers. Okay, a null type device works on the principle of maintaining a zero deflection by applying an appropriate known effect that opposes the one generated by the major quantity. एक simple example कि जो आपकी cranes होती है, okay, so वो cranes जहाँ पे भी अगर suppose कोई भी एक जगह पे आपका मे बी river में या कोई भी जगह पे आपकी कार या कोई एक particular dead weight है, उसको अगर lift करना होगा, okay, तो क्या होगा, same weight जो है, suppose अगर एक कोई कार है which is having a weight of suppose 500 kg, okay, and obviously एक particular hook से वो कार को lift करेंगे 500 kg, the same weight has to be applied from the opposite end. Okay, जो उसका plunger होता है वो self weight apply करता है. उससे भी simple example ले लो, you are standing at over here and you are having suppose 50 kg of the weight, and if you want to lift that 50 kg of the weight, the same weight your legs will apply on the downward side. Okay, so that particular devices which works on this particular principle are called as the null type transducers. Okay, you need to apply equal and opposite weight on the other side to balance both the sides. Okay, so similar devices which are used to balance the units on both the sides. It can be weight, it can be velocity, it can be the pressure. Okay, any particular parameter. The devices which works on this principle are called as null type transducers. And the last one is the deflection type. Any device which shows a particular reading, it comes under the deflection type. So it works on the principle that the measured quantity produces a physical effect that stimulates an analogous effect. Okay, so it can be changes in the pressure, okay, changes in the velocity, changes in the revolution, change in the weight, anything. If you are keep on adding a weight on a particular system, and with the addition of or with the change in the continuous input, you are getting substantial output, you are getting a change in the output response. Okay, those type of the devices comes under the deflection type. Means whatever we are having all the types of except few, okay, which shows the zero reading, except few, all other types comes under the deflection type transducers. There is an increase in the opposite effect until a balance is restored at which stage of the measurement of deflection is carried out. Okay, any particular measurement, whether it is a Bourdon tube pressure measurement using a piston cylinder mechanism, spring balance, any measurement which shows a particular reading, okay, apart from zero, that comes under the deflection type transducer. Okay, so this is about the different classifications of the transducers. Okay, so which we have discussed the 6 different classifications, out of which the 5 are the main important one, while the second transaction type, all those comes under the passive type. Okay, so primarily we are having only 5 classifications. Okay, now quality attributes of the transducer. These are the particular quality, okay, which the transducer is supposed to have. Okay, it depends upon obviously the accuracy or the application point where we are using, whether we are using it for the high accuracy applications or whether we are using it just for the measurement purpose. Okay, just to have a primary guess of the pressure. Okay, if we don't require any exact value, we require just the range. Okay, whether the weight of this object, whether it is 50 kg or 60 kg, around 50 or 60. If you want 50.50 or 50.25 kg, that time we obviously require the transducer which will provide you the accurate or the more accurate result. Now, the first one is obviously the repeatability. We will discuss all these 12. Okay, a definition. Okay, most of the definitions you must be aware about. Okay, repeatability. Okay, transducer must have a high degree of accuracy and repeatability. It means that even after the multiple readings, it should show the same results. That is the repeatability. It means that repeatability is concerned with which one? Accuracy or precision?
Precision.
Accuracy. Precision. Okay. Repeatability concerned with the precision. Okay. Linearity. Okay. It should have a very high degree of linearity within the specified operating range. Okay. Suppose if you are keeping one block. Okay. If you are keeping one block in the weighing machine. Okay. It is recording some reading. If you are in the same weight, the same reading. So linearity, it means that with the simultaneous increase in the output, it should show the simultaneous increase or decrease or changes in the output. Okay, so that is the meaning of the linearity. Dynamic response, okay, it should be instantaneous. Okay, obviously each and every device takes some time because there are multiple sensors and transducers. Okay, and we are passing one signal into the another, means energy is transferring from one phase to the another phase or one form to the another form. Multiple changes in the forms is obviously possible if you are having the multiple stages. So that requires certain time. Okay, but make sure that we need to make sure that the transducer should have a dynamic response. It means that the output should be displayed as quickly as possible. That is the dynamic response. It means that if you are changing the input, okay, the change in the output should be instantaneous. That should not take more time. Impedance. What is the meaning of impedance? Anyone knows? Resistance. Okay, impedance is obviously the resistance. Good. Yes. Okay, that comes under the electrical parameter. Okay, but simply you can say the resistance. Okay, it should have a high input impedance and a low output impedance for loading effect elimination. If you want to eliminate the loading effect, okay, it should have the high input impedance. Impedance should be high for the input and obviously low for the output because we are concerned with the output response. Okay, high resolution, that is obviously concerned with the accuracy. Okay, it should have a good resolution over the complete selected range. Resolution is again concerned with the one more parameter which we already discussed. Resolution is majorly related with the least count. Okay, so high resolution means high least count. It means that more accuracy. That's why it is resolution is directly connected with the accuracy. If we are having the higher least count, ultimately, obviously, it will have the good accuracy. Size, the size of the transducer should be preferably small. Okay, so it depends on the use. And size, obviously, for any, whether it is transducer or any particular equipment, okay, our aim is to have the compact. Okay, so that also saves the material as well as addition of certain devices. Okay, so that will save the cost. Hysteresis means, what is the meaning? We already discussed again. Hysteresis also discussed in the second chapter of the chapter. Lag. Okay, hysteresis means the lag. The transducer should possess low or no hysteresis. Okay, it means that the lag between the mean value or the or the difference between the ideal value and the measured value. Okay, so that lag should not be there. Hysteresis means, obviously, if you are going the increment and the decrement, okay, whether we are measuring from the increase and the decrease, the lag between these two, increment and decrement, is called as the hysteresis lag. Okay, that should be minimum or without any particular hysteresis. The transducer should be in such a way that it should not have any hysteresis or the minimal one hysteresis. Robustness, it should be able to endure higher pressures, vibrations, shocks and rough handling. Okay, it should be robust so that due to the shocks, vibration, it should not get damaged. Okay. Adaptability, should be capable of working in a corrosive environment. It depends what is the input and what is the not the output, obviously depends for which quantities we are using that particular transducer. So it should be capable of working in a corrosive environment. Sensitivity, it should be highly sensitive so that the error should be the least one. Okay, so cross sensitivity of the transducer should be 0 or minimum, and it should exhibit high sensitivity to the desired signal. Right? Stability and reliability, high degree of stability and reliability, okay, so that we can use it for the wide range of inputs. Okay, and stability means so that it will give the accurate value. Response, it should have a quick response, obviously, okay, with the change in the input, which is again related with the dynamic response. Okay, it should have a requisite time domain specification of transient and frequency response. Both are interlinked with each other. Okay, so these are the 12 quality attributes, okay, which should any particular transducer should possess. Ultimately, again, it depends whether it is used for the high accuracy or whether it is just used to record the range of the output. If you want to record just the range of the output, then it doesn't require all these particular parameters. Okay, if you are considering all the 12 characteristics in a transducer, obviously its cost will be very high, right? So if our demand is the higher accuracy, then ultimately it should have all these particular characteristics. Okay, so as per the demand or as per the requirement, okay, the quality attributes might change. Clear? Without any other? So listen.